Hello dear students, we are back again to complete the second part of chlorination reaction of benzene. We dealt with the previous episode that benzene undergoes chlorination to give you chlorobenzene. We are carrying on with the chlorination where right now we'll start taking chlorobenzene. And we will perform chlorination reaction of this chlorobenzene. So this is your following part of the previous episode of chlorination of benzene. We are performing chlorination. We discussed in last episode the catalyst required is precise specific catalyst, and if you remember it was ferric chloride. We are continuing with the same catalyst here as well. Now you know the chlorination mechanism very clearly. So now we are again dealing with one more extra part, that is the position of the incoming chlorine on benzene, where this chlorine is going to situate itself. So that again gets onto the existing group that we discussed during nitration reaction and sulfonation reaction of benzene. Right? Okay. So here this Cl, which is existing on benzene, has got the directive effect. It has got the directing property to direct the incoming group onto a specific or precise position. Here you can see Cl is originally Cl, as you know, it's a electronegative element. It is rich with electron. It has the tendency to gain electron from the atom to which it is bonded. In the previous episodes of sulfonation and nitration, we had seen that it was NO2 group and SO3H group, and the directing effect was according to those groups present on the benzene nucleus. This time it will be decided by the Cl group which is present on the benzene nucleus. Now this Cl group, you know there are three possibilities of the position: one ortho, one meta and one para. As far as the chlorine on benzene concerned, which is electronegative, it has got two directive effects, that is ortho as well as para. Means it will simultaneously direct the incoming group on ortho as well as para positions. Earlier, you know, NO2 plus and SO3H plus, they were meta directing groups. So I would simply say that this Cl is an ortho para directing group. The reason I have already given you. So due to that, the incoming Cl2, right, which is acting as a reagent over here for the reaction named chlorination, will be directed on ortho. Ortho, you know, it is an adjacent position to the existing group, and para is the opposite position to the existing group. So how the reaction proceeds? First of all, the mechanism I will take in a brief. Cl2 ionizes into Cl plus and Cl minus. We have got FeCl3. We have already discussed in the previous part of this reaction. It will attract the Cl minus towards it, and that will be forming FeCl4 minus with Cl plus, that is your chloronium ion, which is participating in the reaction. This chloronium ion gets attracted on the benzene nucleus, but this time it has to get directed according to the already existing Cl atom on benzene ring. So what we'll do for simplicity, for balancing the reaction, we'll take over here 2 moles of chlorine. Fine, so that it gets balanced, because we are going to add 2 Cl on 2 positions, ortho as well as para. This Cl being an OP directing, ortho and para directing, what will happen? The Cl plus which gets introduced, one Cl of the 2 will get on ortho and another Cl will get introduced onto the para position. So here we have Cl plus getting bonded to the carbon, and so you can see we are utilizing 2 Cl. The 2H atoms which were bonded to carbon gets eliminated, leaving their electrons behind, and so they are now H plus. So we have one H plus from ortho, one H plus from para, so we have 2 H plus. On the other hand, we have 2 Cl minus because we have taken 2 moles of chlorine, total 4 atoms. उसमें से 2 प्लस चार्ज में कन्वर्ट हो गए, तो 2 बाकी के जो बच गए, they are in the minus charge. So we have 2 Cl minus combining with 2 H plus, and as a result the byproduct formed is 2 moles of HCl, hydrochloric acid. Here the compound formed is, position is ortho, you can see it is adjacent, so we'll write ortho O. They are 2, so I'll write di for 2. They are 2 Cl, so I'll write chloro, and the compound is benzene. On the other hand, you have 2 Cl at para position, opposite position, para P. They are 2, so we write di. They are what? Cl, so we write chloro, and they are bonded on benzene. So the name goes this way as ortho dichlorobenzene and para dichlorobenzene. That is the final product of chlorobenzene undergoing chlorination reaction. The overall reaction, as I said earlier, occurs in presence of heat or sunlight. That is the condition always there, and the important part is, once the Cl minus is utilized over here and H2H atoms combines with that Cl minus, again what is reformed is FeCl3, which is obtained back as the reaction gets over. So here ferric chloride once again acts as a catalyst, and this is the second part of chlorination of benzene, right? So I have just tried to brief this reaction as it is the second part of the previous one, because in the first part we understood the whole mechanism very thoroughly. So this is how you can get ortho dichlorobenzene and para dichlorobenzene from chlorobenzene. So overall there are 2 steps. In the first step, benzene got chlorinated to give you chlorobenzene. In the second step, chlorobenzene was chlorinated to give you ortho dichloro and para dichlorobenzene. I hope, dear students, you have understood the reaction thoroughly. Even though if you have some questions, whatever the video, the episode you are watching, do write the post comments over there itself and raise your questions. I'll try to clarify your queries, or else you can get on to my email address styrene1411@gmail.com, or otherwise for any further episodes, any further chemistry related topics and its discussion, you can get on to Saurin.S.Mehta and write chemistry. So you will get onto my YouTube channel. Till then, we'll come with next electrophilic substitution reaction. Instead of chlorination, I'll take bromination. Fine. We'll discuss in brief because every mechanism remains the same. So we'll take bromination after this. So complete this thoroughly, understand this thoroughly, come back for bromination. Till then, have a nice time and do take care of yourself. Goodbye.